Good morning, my name is Jorge and I'm here to present the paper I did with André and Paula entitled When Headers Are Not There, Design and User Evaluation of an Automatic Topicalization and Labeling Tool to Aid the Exploration of Web Documents by Blind Users. So for the introduction, to give a context of the problem we were investigating, as we all know, the internet has become this massive source of information, and this helps people with impairments to become more independent because of this ease of access, but it comes with some obstacles. And in this paper, we focused on people with visual impairment because to access computers, they make use of screen readers, which are software that read aloud everything on the screen. And as such, this process is linear, so they can't read diagonally or do the dynamic reading, and which makes the process slow. And on top of that, they have difficulties when accessing web pages, because some web pages have dynamic content, or they can refresh themselves, or they can be incorrectly marked up. And this contributes for a high cognitive load when doing these tasks, which makes them more fatigued. Also, screen readers have shortcuts. I bring here two studies that were surveys, one from North America and Europe, and the other one from Everest, which was in Brazil. And we can see that aside from reading the whole page, which was the most popular in Brazil, when using shortcuts, the most popular navigation technique was using headings of the web page. So that's why we focused on headings. And because of that, we proposed an algorithm that could automatically generate headings for when you have a large piece of text or you find a web page that has incorrect markup on headings to help visually impaired users when seeking information online. And this project was divided in two stages. The first one was developing the algorithms to generate headings, and the second one was to test the results with our target users. So going over some concepts that need to be explained. The first algorithm we developed was the topic segmentation one. And basically, it's the task of splitting a document by finding topic boundaries. So if you have a document about dogs, you can have text about food or about how to take care of them, which would be two subtopics. And our goal is to find the boundary, the place where the topic changes. You can do that by analyzing just the words from the text or using external sources, such as language models. In the case of Niley, she used word embeddings to analyze text. And what are word embeddings? They are basically representations in a space of each word of a vocabulary. These spaces can be of hundreds or thousands of dimensions. And here I bring an example with 2 dimensions because it's easier to look at. And we can see that words that are more closely related, they are also close on the representation. So on the left of this graph, we see the countries, and to the right, you can see their respective capitals aligned vertically. So we can use distance to calculate the similarity between words. And we also have a labeling algorithm, which basically assigns a phrase or words to represent topics of a document. In our case, we are going to consider each topic segment a document. And you can use co-occurrence of n-grams, which are words that go often together, just like user experience. We can use top N words, which are the most frequent words on the text, or external sources, such as using Wikipedia article titles to label your documents. In our case, we used top N words. So for the method, as I said before, we first developed the algorithm, and here's the framework of our algorithm. We can see the input text going through the topic segmenting algorithm. SBERT is the word embedding we used for our algorithm to calculate similarity between each sentence of the text, which creates this matrix of similarities, where the darker the squares, the more different the sentences are. Then we apply a filter to make these differences more highlighted. and we try to group these sentences based on how similar they are together, creating these clusters. And with that, we have a list of topic segments that's then passed through the topic labeling algorithm, which basically ranks the words in each topic segment. And we take 10 of these, the most frequent words, and group them based on the synonyms. And then we re-rank them considering the synonyms. This is done so we can avoid cases where two words with very close meaning are used on the label, which would be a waste of space. And then the output is our marked text with headers. And the number of words that are in the label varies with the size of the text. So in this large topic segment, we can see that we have 5 words, and I've marked which word contributed with which using underline, bold, and italics, as well as colors. And in this case, we have a smaller piece of text that only has 3 words on the label because of its size. For the user study, we had 8 participants with visual impairment, and the inclusion criteria was having little or no residual vision. They all had to be high school graduates, and because of the pandemic, we needed to do the user study online, so they had to have experience with screen readers and computers. We ended up with 6 men and 2 women, aged from 22 to 68. 5 had total blindness, 2 had residual light, and 1 of them had movement perception. 5 of them had intermediate experience with screen readers, and 3 of them were advanced. The test procedure consisted of 4 expositive texts of 700 to 1100 words, and for each text we had 3 questions that needed to be answered by the participants. And they were allowed to use whichever preferred reading strategy, whichever shortcuts, or the speed. They were allowed to navigate as they usually do. We didn't want to influence on how they interact with the text. And after each task, we measured the cognitive load they felt, which is how much effort they needed to complete each task. And this varied between 1 very low and 10 very high. And we also timed each task. And for the scenarios, we had 2. We divided them in 2 groups. One group had texts 1 and 2 with headings generated by the algorithm. They were preprocessed. And text 3 and 4 without headings. The second group was the opposite. So text 3 and 4 had headings generated, and text 1 and 2 didn't have any headings. So for the results of our user study, we can see that the cognitive load scores decreased on the scenario with headers, which is good, means that they needed less effort, but it wasn't statistically significant because of we didn't have that much participants. And the same thing happened with time taken in each task. We can see that in most cases, participants needed less time to complete tasks with headers, but it wasn't statistically significant. And for the participant feedback, we did an interview with them at the end of the user study, and 4 of them said the labels helped when they tried to complete tasks. So this is talking about only the labels, the words that were in the headings. Participant 2 said that he felt like he was running his eye over the text because the labels highlight the most important words theoretically. And participant 5 said that it helped him, but more for a second read than the first one. 5 of them said that they were able to guess what was the topic content based on the header. Participant 2 said that it helped him when he was searching for information. But participant 5, on the other hand, said that for him, the headers didn't make much sense. He said that it was just a grouping of words that didn't have any meaning. And participant 6 said that he noticed that the headers helped him find information, but he didn't use as much. But simply by having headers, highlighting these words made reading less exhausting. And all of them agreed that having headers inside the text helped with navigation because they could quickly create checkpoints in their minds to know where they should go back when trying to refine some information. And participant 6 said that it was useful also because he could use the shortcut for navigating through headings, which gives him agility. So for some design implications we observed in this user study, we found out that dividing text into segments helped screen reader users to navigate and explore documents and helps them creating this mental map so they know more or less where something is. And the text navigation with screen readers is still limited. They were happy to see a new alternative for navigating, and they said that the current ones are too restrictive. You don't have much freedom to navigate inside text. You can only jump from lines or paragraphs, which isn't useful when you kind of know where something is, but it takes some time to find. And we also saw that Brazilian users, even when they use shortcuts, they prefer to first navigate through the whole page to know what is in it, to map it, and then they start using shortcuts. Maybe they fear missing information. So for the conclusion, going over what we've done, we investigated the use of headers generated automatically to help screen reader users in information seeking tasks. And we did that by implementing a topic segmentation algorithm using BERT and a labeling algorithm. And our study with 8 users had positive feedbacks to the proposed plugin. And our results also showed an improvement in performance of participants in tasks with in scenarios with the headings. But further research is still needed to confirm this improvement of performance. And we think that the proposed algorithm or the proposed plugin has potential to improve the lives of screen reader users. And for future work, we still need to explore other segmentation and labeling techniques, mostly the labeling techniques because the users found them of not much use, as we could see on the feedback. So we think that using word sense disambiguation and syntax trees to generate labels can result in more meaningful phrases. And also the segmentation algorithm was very slow. That's why we used preprocessed text. We need to find out a way of doing that quicker. And we still also need to implement the screen reader plugin, but with that done, we believe that we can improve the lives of screen reader users. And this is the end of my presentation. Here are references. And I'd like to thank you for your time and your patience. And you please feel free to ask me questions.